Hey everyone, in this video we're going to be talking about confidence intervals for proportions. We're going to go into a lot of detail here, so let's get started. Alright, so we're going to pull up a notepad and we're going to explain what a confidence interval for proportions really means. So let's see here. There we go. Now I have everything open. Now here's the idea. Let's suppose Apple claims that, ooh, that's a bad P there. Apple says that 80% of users are male. Now that's quite a claim to make. And suppose what I decide to do is I actually gather my own sample here. This is my sample, and in total it has 1,000 people. And I find that literally half are male. So just from looking at this image here, it looks like Apple is wrong, right? I mean, I surveyed 1,000 people. That's quite a bit. And 50% were male. Whereas Apple is saying 80% of the population of Apple users is male. That doesn't look like the case. But this question of, the question here is 80% close to 50%. Are these two numbers close, 80% and 50%? And, well, if we ever want to measure closeness, we've already talked about how to do that. The answer is confidence intervals. So, real quick, how do you calculate a confidence interval? Well, we've actually seen this formula before. Let me use green now. The formula in general is something like some average plus or minus T star times the sample standard deviation divided by the square root of n. Now real quick, that right there is an average. That x bar is literally an average. But I mean, we're not really calculating an average here. I mean, I'm asking the Apple users, are you a male or are you a female? The answer isn't numerical in nature, so this really is not an average. This should be a proportion. So should be P. Now some people use P hat. I'm going to use P hat too. Should be P hat. I mean, it doesn't really matter whether you not use P or P hat, but it should be a proportion. It shouldn't be like an average of something. So in this case, that should be my 50% in theory. If I were to do this correctly. So let me erase some things to make myself some room here and show you what I mean. This should be like 0.5 or 50%. Doesn't really matter. I prefer 0.5 because we're talking about a proportion here. Half of Apple users that I sampled were male, plus or minus, and now we have to use T star. I would use the chart to figure out what that number is. I know how to do that. I have 1,000 people. I can do that. I know what the number of people there are. There's 1,000 people there. But standard deviation, what is the standard deviation of my data? Well, how can I calculate that? Oh, you know what? I have an idea. We can calculate this using that 5-step process. Do you guys remember the 5-step process? The 5-step process was the following. First step is calculate the average. Okay, well, I can't really do that. I can calculate the proportion, like the 50%. So I guess 50%. Maybe I could put that there. What's the second step? The second step was find the distances from the average. Find distances from average. Yikes, you know what? That word right there, distances. That is a huge problem because what do I mean by the distance from 50%? I guess I could mean like if someone chooses, or if someone is a male, then I guess that's like 100%. If someone's a female, that's like a 0% or something like that. Like, what do I really mean by distance here? And this is where things begin to fall apart. And then we start doing things with those distances. And this really does not work. This method of calculating standard deviation does not work. And the reason for that is because in this case, we are working with, and this is a key note if you want to write this down, we are working with qualitative data. That's really important, guys. We're working with qualitative data. Now, when we're working with quantitative data, we can calculate the average, we can find the distances from the average, we can square those numbers, we can add them all up and divide by the total number of numbers minus 1, and then we can square root. Those are the 5 steps for calculating standard deviation. But in this case, we can't do that because we're working with qualitative data. If someone says, I'm a male, I can't really find the distance of that from that to the average. That's not a thing. So when it comes to qualitative data, how do I find the standard deviation when we're talking about proportions? Well, there's actually a method of doing that. The method is, I'm actually going to give you this formula. It is the square root of the proportion times 1 minus the proportion. Now, in theory, this is actually true for the sample standard deviation and the population standard deviation. However, you don't know what the proportion of the population is. That's why you're trying to guess it using this value right here. So for that reason, we just use the proportions, the statistic that you gather, and we assume that's the parameter. And by doing so, you have to use T star. T star is always what you use if you calculate the sample standard deviation. If you ever calculate the standard deviation, then you have to use T star. T star is always greater than Z star. Always, 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 because you need to be penalized for not sampling enough people. And so T star kind of accommodates for that, for the fact that you're using this guy, and let me use a different color here. You use this guy and not that guy. When this guy is technically necessary, we should be using this guy, but we literally cannot calculate that. And so we use an estimator, which is this guy, and because of that, we need to use T star as a penalty for our confidence interval. And so now I'm going to give you guys the formula for confidence intervals for proportions. So this is confidence intervals for proportions. This is the formula. It is essentially the same thing. The proportion that you calculated, plus or minus T star times the sample standard deviation over the square root of n. It looks almost identical, but the only difference is the sample standard deviation is calculated by taking the square root of p hat times 1 minus p hat. Now, I do want to mention a lot of textbooks will actually talk about this a little bit more in detail, this guy right here. Because in some cases, if your sample size is a little bit too small, or your proportion statistic is a little bit close to the boundaries of 100% or 0%, sometimes this might not work. And so I think the solution to that is to gather enough. I think you have to gather a big sample size and do something with this. I can't remember what the formula was, but it's irrelevant. The idea is you should gather a large sample size if you actually want to effectively use this and make a confidence interval that works. And that's kind of the theme of pretty much every study, if you will. So anyways, this is how you gather this is how you develop a confidence interval for proportions. Now you might get a confidence interval that might look like something like 0.2 and 0.6. And let's say this is a representative of Republicans. Well, what does this mean? This means that you are certain, let's say we need to talk about percentage of confidence. We would say maybe 95%. And this is dependent on which T star you use. I would say I'm 95% confident that between 20 to 60% of the population is Republican. So I am 95% confident that between 20 to 60% of the population is Republican. And by the way, whenever you do confidence intervals for proportions, if it's a binary question like Republican, Democrat, male, female, if it's binary, you can actually say exactly the same thing for the opposite data, but you have to flip across on the other side. That would mean that 95%, with 95% confidence, that I think it's 0.4 in this case to 0.8. Let me explain why. We would also be 95% certain that between 40 to 80% are Democrats. Now, where did I get those two numbers from, this first confidence interval here? How did I get this when I only had that? The answer is, well, if 20% are Republicans, then 80% are Democrats. If 60% are Republicans, then 40% are Democrats. And so you can actually develop the other side of the confidence interval if it's a binary qualitative data, if it's a binary value for the variable. So if there are only two options that you give for the statistic that you're measuring, then or for the question that you're asking, there are only two answer choices, then this is a really good way of developing two confidence intervals simultaneously. Anyways, in the next lecture, we're going to be talking about t-tests. So we're going to be addressing essentially how we tackle Apple when it makes a claim like 50% of its users are male, or 80. They say claimed 80% are male, and we claim that 50% are male. So we'll talk about that in the next lecture.